All right, well, welcome everyone to this session on debugging code on Kubernetes. My name is Mark Foley. I'm a senior solution engineer with VMware based in Brisbane, Australia. I'm not going to be doing this presentation today by myself. I've actually got a colleague here who will be joining me. Sharman, would you like to quickly introduce yourself?
Absolutely, Mark. So hi, everyone. My name is Sharman Kiani, and I'm an associate solution engineer here at VMware. I've been with the company for around about 18 months now, and I'm loving every bit of it. Diving in and learning about Kubernetes has been so much fun, so much so that Mark and I decided to team up once again and do this presentation for VMworld. So Mark, what do you say? Let's dive into this presentation.
Yeah, sure. So firstly, look, the obligatory disclaimer slide. So probably not really applicable to this session. So we're not going to be doing too much with VMware products. However, I have to show it to you anyway. So consider yourself shown. So I just want to start off with a little bit of background to this session. So a few months ago, I was working on a Kubernetes project and I came across a bug in my code, at least I suspected it was my code, and I just could not find what was causing it using the usual methods I go to, which in general, what I tend to do is I look at log files, I have an observability tool that I use, I look at that. I will run the code in my local test harness on my laptop. But all those things, just for some reason, I could not find this particular issue. And I ended up in a situation where I wanted to be able to debug this code on the Kubernetes cluster. So I actually stepped through the code while it was running in a production environment. Now, this led me to a little bit of a rat hole. I'm familiar with things like remote debugging. I've used it a lot in the past, but just getting that working in a Kubernetes environment and just some of the pain involved led me to think, well, there should be a better way than this. So really, this session is a bit of a summary of lessons learned from, I guess, what ended up being a good 3 or 4 days diving into what are the options for effectively debugging on Kubernetes. And as a result of that little piece of work, I've basically come up with really what I consider to be the 2 high-level approaches to debugging on Kubernetes. And just a warning, this particular session is not going to be overly prescriptive. The reality is, when we're debugging on Kubernetes, you have a choice of a variety of programming languages you want to use. And often debugging can be very specific to the programming language. So really, this is more about the principles and what principles apply. So when we look at debugging on Kubernetes, ultimately, there seem to be 2 high-level approaches that are common and seem to make a lot of sense. One of those I mentioned earlier, remote debugging, and that's something that's been around for a while. It is something that is provided by most programming languages. So the ability to get a debugging tool and be able to remotely connect it to a piece of code running on the network. So effectively an IP connection between a debugger and a piece of code running in debug mode. That stuff's been around for ages. I remember using that when I first started programming. See the grey hair, that was a long time ago. So it's pretty sort of standard stuff. So when I hit my issue with Kubernetes, this is the approach I end up doing, right? So doing remote debugging. That has some problems though. And, that led me to look for, well, what are some of the other things we can do? And the other category of approach that is really popular, and I find addresses a lot of the issues with remote debugging, is something that I call proxy and simulate. Effectively, what we're doing is we are redirecting traffic from our Kubernetes cluster to the code that's running on our laptop, but is running in a simulated environment. So effectively, we're using tooling to simulate a Kubernetes environment on our laptop. And so that's quite an interesting approach. And as I say, it addresses some of the shortcomings of remote debugging, but in turn has some shortcomings of its own. So just to kind of go into and look at some of the pros and cons of these approaches, we want to go into each of these a little bit deeper. So we're going to start off with remote debugging. And I'm going to turn over to Sharman here and just get her to give you an overview of what remote debugging looks like in the scenario we're going to go through.
Absolutely, Mark. So what Mark has shown you on this slide itself is essentially an application, a web application we're running remotely. So that could be any remote Kubernetes cluster that we've got set up. And as part of that cluster, we've got multiple separate pods running. Each one of those pods is in charge of one of the services as per that application, and it might be running code specific to that specific service itself. So we run the code. We've found that there's actually an issue that lies between one of those pods and the code that exists within that. And we've happened to find that that pod itself is pod number 1. So in this situation where we come across a bug, what does remote debugging look like? Well, first of all, we would have to deploy a debug version of the pod or service itself. Once we've done that, then we would deploy and attach a debugger and link it to that specific service, which we've identified the issue to lie within, or the bug itself. The example Mark will show you here happens to use Go language itself, and he's using Visual Studio as a debugger. Now, I say it happens to be using Go language because the IDE and the language you use can change. It doesn't really need to follow a standard path, but the principles here should stand or be consistent throughout the whole process. And that's just one of the main takeaways to take from here. So Mark, do you want to show them through a demonstration what this process of remote debugging would look like?
Yeah, sure. So thanks, Shaman. So let me just go into my Visual Studio Code environment and it's not where I want to be. Go into my Visual Studio Code environment and really start off from where I want to finish off, right? So I'm in Visual Studio Code. I am in debug mode, and you'll see I have a breakpoint on a piece of code. So this is where I want to be, right? Debugging that code. And right now that code is running on my remote Kubernetes cluster. So most of you, I'm pretty sure the audience here, you're all developers, you're all familiar with debuggers. At the end of the day, in the vast majority of programming languages, there's very little difference between remote debugging and local debugging. So all the capabilities are the same. Question is, how did I get here? What are the things I had to do to get to this particular point? So let's just stop this debugging session and look at the setup that was required to get here. Now, as Shaman said, one of the first things you're going to need to do, if not the first thing you need to do, is deploy a debug version of your code base to the Kubernetes cluster. So in all programming languages that I'm aware of, there is at least one change you'll need to make to the container to allow it to run in debug mode. In some cases, there'll be multiple changes you need to make. And the reason I chose Go as a programming language, it's one of those ones where you actually need to make multiple changes to get your code running in debug mode. So usually, and what you're going to need to do is you have your production Docker file here, which you can see. In general, to get a debug version of your build, what you're going to need to do is create a debug version of the Docker file, which is this one here. And effectively, the two changes I need to make with Go, I need to change the build process. So in this case, I'm creating a debug build, so including all the debug information into the generated executable. So it's a different build command from one we would use for production. And then the other change I need to make, which is going to be almost universal to all programming languages, is actually change the startup command so that I'm starting this piece of code in debug mode. So in the case of code, in the case of Go, the way we start our code in debug mode is use a tool called delve. And then also I'm needing to pass a whole lot of parameters to tell delve I want to run in remote debug mode. And I also need to specify things like the port that the debugging port that is going to listen to on. So step one, right? You're going to need to generate a new container that has that debug version of the code running in it and is set up for debugging. Next step is basically optional. You don't have to do this, but I quite like to do this. You're going to, in this case, what I've done is I have a debug version of my deployment descriptor for this particular service and pod. So what I have done is as we indicated earlier, the debugger needs to connect to that pod over a specific port. So we're going to need to open up that port to basically expose a port on our pod. There's a couple of ways you can do this. I've chosen to do this via a service. The other way you can do it is by using a port forward on Kubernetes. There's advantages and disadvantages to both approaches. With using a service like I've done, it means it's just a single step. So as part of your deployment, you're automatically exposing that code. With the port forward, that's just another step you have to go through. Disadvantage with using the service though is it really only works when you have one instance of a container as part of a deployment. So if you have multiple replicas in your deployment, that's going to cause havoc as the service tries to load balance between the different replicas. It's just simply not going to work. So there are some pros and cons of both approaches, but I usually choose to use a service. Then we're ready, right? I can just simply use this deployment descriptor and deploy that debug code into my cluster and be ready to start debugging that code. So that is basically the process of remote debugging. So, Shaman, what does that look like? I mean, what do you think of that? You're on mute there, Shaman.
I guess step one would be to be off mute, and I got to put money into that jar as well. But yes, it looks great to me, Mark, but I just wanted to know what happens when you make a code change as a result of this.
Yeah, and that is probably the biggest issue with remote debugging. So, you know, when we think about normal debugging, the traditional, you know, development on our laptop, debug, inspect, and retry cycle, that's pretty quick, right? We get feedback right away. You know, we do a little bit of coding, then we will go and build our code, inspect it, and then we can hopefully see what the issue is, see what we think the issue is, make the change and try again. And it's a nice, quick feedback cycle, and we're usually pretty productive when we're doing that. The problem with remote debugging is that, you know, one, we've got to do all that setup. That's a bit of a pain, but mostly okay. And, you know, in some cases, we're able to automate that setup. Problem is, though, that when we make a code change, to have that change take effect, we're going to have to rebuild our container and then go and deploy that modified container to our Kubernetes cluster, and that takes time. You know, I've sort of in this diagram, it indicates in this case it takes 4 minutes. You might be lucky, maybe it's less than that. It can be a lot more. You know, I've seen containers that take 10, 15 minutes to build, for instance. So the issue is that you've taken a nice, quick process of code, inspect, change, and, you know, being able to execute that cycle very quickly to one that introduce every time minutes and sometimes even tens of minutes of delay into that cycle. So it's a real impact on productivity, and it's really going to impact how long it takes you to identify and fix bugs. So from my point of view, this I found is absolutely the biggest hassle with remote debugging, and it's what led me to basically look for what are the other options that are out there. And that effectively leads us to the second approach that I pointed out at the start of this presentation, which Shaman's going to demonstrate, and I call proxy and simulate. So this requires tooling. There's a range of different tools out there in the market that you can use, quite a few open source, there's some commercial ones as well, but they all take a fairly similar approach. You know, we have the same scenario here where we have a pod sitting in our cluster, and that pod we've identified, we think there's a bug in there and we want to be able to debug that pod. What we do is, rather than implement remote debugging, our tooling, we use our tooling to basically deploy what we call a proxy. What happens is the proxy intercepts the traffic to the pod of interest and redirects that traffic to a local process running on our laptop. What happens is the tooling is also installed on our laptop, and the tooling provides, if you like, a dummy environment for that local process. So for instance, the tool we're using makes some changes to DNS on our laptop. So DNS entries for these other pods are actually available to that local process. And there's a few other things we do to make that local process think it's running in a Kubernetes type environment. In the case of demo that Shaman's going to do, that local process is actually something that's running under a debugger running on that laptop. So effectively what we're doing is we are effectively debugging on our laptop, but it looks very much like we're on a Kubernetes environment. You know, we're running in the same environment as Kubernetes, and we're having the same interaction with all the other components of our application as we would in the Kubernetes cluster. So the example Sharma's going to show you is using something called telepresence, which is a CNCF project, so fully open source. You can download it today and start using it right away. And in this case, Visual Studio Code with the Python language. So Sharman, over to you. I'm going to stop sharing my screen now and let you share yours and walk us through your demonstration.
Sounds great to me, Mark. Say yes when you can actually see my screen now.
Certainly can. Thank you.
Perfect. That's awesome. So what I'll start off with firstly is just showing you that remote Kubernetes cluster that I've got running. So you can see that I have a web application running, and as part of that web application, and what Mark's shown you is essentially 3 pods, and each one of those pods is in charge of a service and has code in reference to that too. Now, what I'll show you is the status of telepresence itself. What it's showing you right now is that I have the root and user daemon installed. So I have telepresence as itself installed. I didn't really want to go through that process with you just because it's trivial. It's not that hard to follow through, but what I really wanted to show you here is that even though it's installed, it's not connected. And by what I mean by not connected is that it's established the fact that I have a remote cluster running. It's just not essentially created that tunnel between my workstation or my local workstation here and that remote Kubernetes cluster that I just showed you there. So what I'll do is I'll run telepresence connect, put in my password. It should be a very fast process to follow through. And once it does that, it'll show me straight away or which context it's recognized on my device here on my local workstation. And it'll establish that connection between my local workstation, which I'm on right now, and that Google Kubernetes remote cluster that's running with my web application there. What I also want to show you is essentially my front-end services code running in VS Studio here, Visual Studio. It's running Python code itself. And just as it would follow any specific process when it comes to debugging, I put in a lot of breakpoints here. So when I do run the code, it'll examine the code itself and hit this breakpoint here. So what I'll do now is essentially establish that intercept. So what is an intercept and how can I see all the services that I can intercept traffic for? When I do telepresence list, I should be able to see all of the different services as part of my Kubernetes, remote Kubernetes cluster. And telepresence will tell me these are the services I can establish that rule for. Intercepts allows me to establish rules so that instead of traffic flowing through my remote cluster, if I've identified the problem to exist for pod 1, that's where the bug lies, and I intercept traffic for that, instead of traveling between the remote cluster, it's going to essentially deploy that proxy against pod 1 and bidirect all of that traffic against my local workstation. So I can make changes on the fly using Visual Studio, and it still has contact with my other services in the remote cluster, and it will see what effect that has as a change against those services. So let's go ahead and telepresence, intercept, and I'm going to establish that intercept for that first service here. I'm going to establish a port 3000 because that's where the traffic is conversating against, and I can see that here as well in the kubectl get services output. It shouldn't take too long to establish that intercept, and you can see that it's already created here. If I do telepresence list, I should be able to see which services I've created that intercept for, and I can successfully see that it's now directing all the traffic destined for this specific service against my local workstation. So if I go here and I go ahead and run the debugger now, it will essentially start up the Python server. It'll go through my code and it should hit this breakpoint here where it essentially grabs that color. And if I go back to the front end on my workstation, on my web application, and I reload, it will straight away run through the course and hit this breakpoint against my code, and then I can start debugging itself. I'm going to remove this and I'm going to make a change now. I'm going to show you how fast that process of making changes and seeing how it impacts overall the cluster. So I'm going to change this to blue. I'm going to run it against. It's going to run the Python server again. And once I come back here, I should be able to see how fast that change occurs. It's probably just going through. I need to save this quickly. Perfect. I'm going to stop it and I'm going to run it again as well. Perfect. So if I reload this, there you go. Straight away, I can see that change. Once again, I could put in breakpoints all where I want here, just debug the normal process. But what telepresence has allowed me to achieve is essentially a hybrid environment where I have my local workstation running and my remote Kubernetes cluster. I can bidirect traffic for certain service that has an issue and make temporary changes or permanent changes and see how that impacts. And what telepresence does really well is that it cuts up a lot of those extra cycles or extra steps that my development process would have to follow, where Mark had to go ahead, make a change, push it out. I don't need to do that. I can make a change and straight away see that impact. So I'm just going to go back to the slides here and present from the current screen. So what you can see in comparison to remote debugging is incredibly slower in regards to how it executes and is set up. Do you agree, Mark?
Yeah, absolutely, Shaman. I mean, the impact on your workflow is really significant, and certainly I've taken using telepresence where I can. Some of the issues though with telepresence is unfortunately you can't always use it. So it requires your object to be invoked by a service. So if you happen to be using something like a daemon set or a cron job, for instance, they're things that do not get invoked by a service. So you cannot use telepresence to debug those, and you're going to have to go back to remote debugging. Telepresence is very easy to set up, as you showed. You do the connection and then bang, you can just intercept any service. Whereas with remote debugging, unfortunately, that setup is a container by container, pod by pod setup. So it can be quite a painful process. With telepresence, it requires tooling, right? So tooling above and beyond what your programming language provides. So sorry, not with telepresence, with proxy and simulate, it requires that tooling. So telepresence is an example of that tooling. There are others out there. I think Microsoft has something called Bridge to Kubernetes, and I've seen a few other ones as well. Those toolings, their support for different platforms can vary. So you just need to be aware of that. The final thing to be aware of with the proxy and simulate approach is that it is creating a simulated environment for your code to run, and you really are relying on the quality of that simulation. So, for instance, in telepresence, the way you access volumes and environment variables is slightly different if you're running under telepresence to how you're running in a Kubernetes pod. Now, you can write your code in such a way that it's completely, transparent to where it's running, but that can potentially require a code change. The other thing that is really painful and just pretty much really doesn't work that well with the proxy and simulate approach is where you have multiple containers in a pod, and those containers need to communicate. It's really messy, really quickly, and generally in a scenario like that, I would probably end up using remote debugging. So they're really the things to be aware of when you're just thinking about your debugging strategy. Shaman, back to you to close it all out.
Thanks so much, Mark. So once again, I think we both would recommend starting off with proxy and simulate approach. Have a look at all of the other options available to you. Proxy and simulate also makes it very easy for you to work within larger environments. So if you want to collaborate with other people, it's a very friendly option to use. And then if you want to look at, all of the other objects that it doesn't really cover, then you can move towards remote debugging and use it in those circumstances because it does widen that approach. But apart from that, I hope this presentation really stuck out to you. You enjoy listening to it, pieces here and there, you're able to replicate into your own environment and use as practices. We really appreciate you listening on, and we highly recommend you look at the other presentations that VMware Code is offering to you as well in this space. And I really enjoyed working with Mark on this as well. Worked with him previously as well. Really enjoyed it. So in comparison to that, I would also recommend doing the survey itself. So letting us know what works, what doesn't work. If you want us to cover anything else as part of, the ongoing scheme of things is here as well. We would really appreciate it. Mark, anything that you want to add in as we close off?
No, thank you, everyone. Thanks for your time, and appreciate you dropping in, and I hope you enjoy the rest of the conference. Thank you.
See you guys. Bye.
Bye.